Hi, everybody, and welcome to another great episode of the IaC, the Infrastructure as Code podcast. I'm Ohad Meislish, and today we have an amazing celebrity guest. We have Nana from TechWorld with Nana. Hi, Nana. Great having you today.
Hi, thank you for having me.
For those who maybe don't know you yet, can you share a bit about your background and what you do?
Yes, so very briefly, I am a software engineer turned into a DevOps engineer, turned into a DevOps trainer. So right now, what I do full time is basically um, absorbing all the knowledge and all the developments and trends that are happening in DevOps and cloud space and turning that into content in order to teach others. Because I remember when I was an engineer and working full time on, I don't know, setting up Kubernetes clusters or Jenkins pipelines, I rarely had the time next to the job to really go in depth and understand the concepts, understand the trends, and see like maybe there's new technologies and ways of doing things better. And so I try to distill that knowledge and kind of make it easier for the engineers to stay up to date with the developments, but also get into this super exciting and awesome field, which we call DevOps.
That's great. And as a content creator, I think you're probably the leading content creator in the DevOps world. I just mentioned, if I remember correctly, you have more than 1 million YouTube subscribers. So this is an amazing achievement and really kudos to you and your great work. I think developers know how to appreciate great content. And obviously you're doing a lot of great content. So let's talk about the content and the developers that learn so much from you. When I try to look at the last 20 years or so, I feel that if you needed to manage infrastructure for companies 20 years ago, you worked with some physical infrastructure and literally a screwdriver if you needed to install a router or some networking devices, interfaces in your physical uh, computer, servers, what's not. Then with the virtualization, especially with cloud, you learn uh, how to click the certain GUI button to properly configure and update your infrastructure. But in the last 2 years, it feels that things have shifted to code, and you need to know how to configure Kubernetes YAMLs and Terraform YAMLs or HCL files. So, in order to be helpful to manage the infrastructure, you need to learn different skills every 5 or 10 years. What kind of skills, the most important skills, do you think are needed if, let's say, I want to start my career and to help a company to manage their cloud infrastructure? What would you recommend me to learn and to know? What are the main things?
Yeah, first of all, it was a really good description of the evolution of
Mm,
uh, cloud or generally infrastructure from on premises to cloud, but also that important addition of there was some IT guy in the isolated room, which was literally my experience when I was an intern. We had this one room with one person in it, which was the cloud head. There was just one other person, and that was it. And we engineers, software developers, were sitting in another room, and obviously we were the main team, right? And it was like this isolated, some weird project that they were working
Ta-
on. Uh,
Talking about silos, like this was literally a silo, a different room.
and we knew like there's this cloud thing going on here, but nobody really knew what was happening. And there was another room with servers in it, and they were kind of testing around and working on it. So the main the distinction of going from some guy, doing this configuration on their machines or directly connecting to the servers to everything now is code, so that it moved closer to what developers actually were doing and how they work. That is, I think, the major shift, because that shift from working directly with servers to now writing everything as code abstracted so much away that it automatically involved a series of other changes, right? So for example, the most obvious thing is that we define the blueprint of an infrastructure instead of clicking the buttons or executing some weird scripts on machine. Then the pipeline was added to it, right? So we have now the code that represents how the infrastructure would be created and what configuration it would have. But also now we need to add validations and tests and checks before we apply any configuration changes. Now, if we get a junior engineer on our team who joins the infrastructure team, we don't teach them to go to some people and borrow their scripts or be super careful not to mess up anything in the configuration. Now we can tap into the functionality of Git and collaboration to create merge requests, right? So we actually give them much more space to learn and do stuff with the structure without actually destroying anything in the production, right? And then we can do the same thing as developers are doing, which is applying the infrastructure changes in stages, right? First, let's try the development, then staging and production. Another really important shift that also happened that I remember from my early times as a software engineer, either we didn't have multiple stages, so everything was directly going from development to production, which is crazy.
That's cool. That's the best. That's the best practice.
That's the best practice if you want to have a most stressful release process and event where everybody needs to freeze and fully focus on that for the whole day. Or you have multiple stages and all of them look different. So if you test something on the development environment, prepare for the surprises on staging and on production.
But it works on my machine, so that's all I should care about, right?
And the cool thing is that the shift to what we call infrastructure as code, right? So now we write everything as code. Pipeline is code, infrastructure is code, X is code. A lot of these benefits were kind of byproducts, like probably people didn't really think intentionally about. But the fact that you have a blueprint as code for an infrastructure means that I can destroy an infrastructure and rebuild it in seconds or in minutes, and I can reproduce the replicas of the same environment for dev, staging, production. So there was this chain of improvements and developments that actually followed the change of turning infrastructure creation and configuration into code. So I love this space and I love all the concepts and topics around it. But to answer your question, like it's a world of its own, so to say, with all these developments and shifts that happened.
Definitely. And yeah, with infrastructure as code, as you mentioned, you can get the not exactly replication, but the similarity between your dev, staging, production environments in a way that makes a deployment to dev not 100% sure, but as close as you can to validate the real thing. So that reduces risk. Now, so let's talk about a junior new DevOps developer. Kubernetes is difficult. Before I learned Kubernetes, I used Docker Compose and then Docker Swarm, which is way more intuitive in order to have a cluster of Docker containers. But nobody is using Docker Swarm anymore. So the first thing for you as a DevOps engineer that needs to somehow manage the compute resources where you run the pods and the code that all of the application developers wrote, you probably need to manage that today in Kubernetes. It is difficult. It's not beginner level. What are your tips to guide some junior developer to be able to help that task and challenge for companies that need to manage their infrastructure and use Kubernetes? How do you bridge that gap in a way that this new person will be trustworthy quick enough?
Okay, so that's also a huge topic on its own because of the complexity of Kubernetes, there were so many new concepts that evolved that tried to address the challenge. Like there were abstractions of Kubernetes because they wanted to protect the engineers from this monster and this mysterious thing called Kubernetes. It didn't really work that well because it didn't really set through as a standard in the industry. The second approach was obviously the managed Kubernetes service, where you hide away the abstraction of managing and administering the cluster. So the here's the probably the most useful tip that I could give someone who is scared of Kubernetes, who is a newcomer, and who wants to kind of get into it. First of all, is you need to draw a clear line. In Kubernetes, there are two parts. There is the administration part, which is how do the control plane components work? How do I administer the cluster nodes, right? How do I configure an access to the cluster with the load balancers and ingress? How do I install and configure the kind of managing or administrative components, right? Monitoring and logging and this type of stuff. So that is a side
Advanced. Yeah.
developers, not necessarily advanced, but it's a different role. Like you can be a Kubernetes administrator, which was my first role as a DevOps engineer, but it is completely different. And usually developers do not need any part of this knowledge because
Yep.
developers are the one who need to use the cluster. So they are the user of a Kubernetes cluster. So if you have a managed service or if you have a large company who manages their cluster, you as a developer go and use the resources of an existing cluster. So you usually don't need to deal with that type of complexity. So it's important to understand the difference between that because the usage part is much easier to learn. That's where the pods and deployments and services come in, right? So you can use Kubernetes without even understanding in depth how the architecture or the nodes and the cluster work. Because the magic of Kubernetes is that once it's set up, it kind of works.
It should work. Yeah.
Exactly. The ideal state is that it should work in the background and it can do its magic in the operations because Kubernetes, the way I can summarize it in one sentence, is your automated operations engineer. Like once it's set up, it works 24 hours for you as an operations engineer, as an automated one. So for developers, the first thing is to understand the basic concepts, right? What is a deployment? What is a service? How do I deploy? How do I take my application and which is Dockerized, hopefully, and how do I deploy that in Kubernetes? Like if you do that demo once, you have like 80% of the knowledge to get started, right? And then you can build on top of that knowledge. But really, that's it. Like to get started and to understand the basics is the 20-80 principle, basically. That 80% is those basic components. And Kubernetes has, I don't know, tons of components, but mostly you need just a handful of them. And another advice I can give is try to learn Kubernetes from a use case. Like how do I take my I would say like a small microservices application, which is Dockerized, and how do I deploy it in Kubernetes? If you manage to do that, you have learned like the main core of how to use Kubernetes.
Absolutely. I'm trying to uh, reflect on the structure. You said everything is code, so obviously your, let's say, Java or application code is written in code of the application. And I think today most probably let's talk about the common use case of Kubernetes. So you have some Docker file that represents the Docker image that will run your Java code. So that's the Docker file. Then you need the Kubernetes YAML to reflect how exactly the Docker image and the pod executing that will run within a cluster. And then maybe you have the Terraform code that provisioned originally the EKS or whatever Kubernetes cluster somewhere. And that's how you got the infrastructure. Obviously, you have modern compute and different approaches. You have serverless, you have actual virtual machines. Maybe it's legacy, maybe it's still super common. And and you have RDS and platform as a service for specific things. But I'm just thinking about the main code that is uh, running on Kubernetes. So many places of code, but it's not real, let's say, scripting. It's more a declarative way of the code that represents your infrastructure. However, there are other approaches to use that code, let's say Pulumi, that is more imperative, that you actually write code that execute things like a normal programming language. What are the use cases that you're seeing, and what are the different approaches that you're seeing? As you say, everything is code. Can you zoom in on what you're seeing and what are the trends?
So the first of all, the biggest shift that happened with declarative or I would say stateful infrastructure management was um, if we compare it, so Pulumi also has a state just like Terraform, right? So the big shift there was that you basically define the blueprint or architecture in a way that, and this is also very compliant to Kubernetes, because you say, this is my desired state. I want this to be the end result of my infrastructure. The same way in Kubernetes, you say with deployment, it's like a declarative blueprint, right? YAML that says, I want this number of application replicas running with this state and with this configuration. Give me this as an end result. You don't care how it's done in the background. The magic happens in the background because of the state. Now, we can do whatever Pulumi and Terraform do with Python, right? We use the Bottle library to connect to AWS. We can script every single step. We can say, give me this many EC2 instances, configure this. But if this tool is already installed, skip that installation and instead just exit and then start this service. But if this service is already running, skip that start step and just exit. Or if the instance is already created with this name, ignore the error. So every single step, you need to first of all you need to specify how the program does it, but also you need to check at every single step, is this service already created? Is this folder already created or copied? So you need to do this error checking in every stage, which adds a huge overhead into your code. So I think that is the biggest shift and change from, because that's also infrastructure as code theoretically, but the stateful declarative approach that kind of goes through as a pattern through Kubernetes and infrastructure as code and Docker files, for example, is a huge shift from I need to know what is the end result. And now think about, that's just day one, right? But now think about the configuration management. Now I need to make changes to the infrastructure. Imagine you need to keep track of every single change you make to your infrastructure. Like that would be a nightmare, right? Instead, the tool itself helps you with the state management and says, nothing to be done here. Your new desired state is the same as the old one. Or, oh, you need this thing. Let me make the changes necessary in the background in order to give you the new desired state. And you don't even need to know how that desired state is achieved. So that abstracts away a lot of the complexity of managing the code of infrastructure. So I see that as a huge change. Instead of, in terms of trend, I just see a lot of teams, they're just switching to infrastructure as code, whether they're using cloud or still using their on-premise infrastructure. So that kind of has become the default way, which makes complete sense to me because it's just way easier. Imagine how much resources you save in terms of like your engineers' times. With the fact that you don't have to manage the infrastructure manually or with scripts, you can kind of offload this to a tool. And then collaboration. If your infrastructure team grows, it's just much easier to bring on someone new into your team and say, everything you need to know about our infrastructure, you can read in this Git repository that has the infrastructure as code, right? So, for example, if I think about whether it's a junior or senior engineer, if I join a team and the first thing I would think about, how does your infrastructure look like? Like, where do we start, right? Instead of someone giving me a presentation with architecture diagrams, I can just go into the Git repository and look through the code, and I know exactly what infrastructure resources we're using, how it's set up, why it's set up this way. So it kind of uh, acts as a learning documentation at the same time, which automatically gets updated because to make the update in the infrastructure, you need to update the code, right? Instead of going and forgetting to update the documentation, the structure.
Yeah, I want to say two things about everything you've said in the last few minutes. So the source of truth of your infrastructure becomes the Git repo of your infrastructure as code. That's in theory uh, correct. In reality, and now I'm going to talk about drifts. In reality, you have the code. You're supposed to go through the code when you want to provision changes. But in reality, some engineers still have access to the cloud account, and some might do those changes. Maybe it's something urgent. Maybe they have other tasks and they want to get this thing done and later fix the code and neglect that. Maybe they're not that aware, or maybe they're not too knowledgeable in how to change the code. But for whatever reason, um, yeah, you don't need documentation for your infrastructure because it works as the code. But I just wanted to remind everybody that this is, in reality, probably facing some drift challenges about detection and analysis and potentially remediation that hopefully can be as automated and as fast as possible. Just brainstorming about the implications of now you have two things that should represent the same, but nobody really ensures that it's going to be the same.
This is actually, first of all, this is a great point, and I know that a lot of teams, because the introduction of any tool and concept is very step by step, right? So they introduce the Terraform, and they realize that somehow it only need the central state. So it's like in steps. So the next step of this, or I would say the advanced adoption of a tool, and this is something that I, try to teach every engineer to use in their projects. The best practice is you absolutely need to put guardrails for your infrastructure to avoid people with old habits maybe accidentally doing this stuff. So the best way to rely on engineers is to prevent them from doing this stuff that they're not supposed to do in the first place. So for example, if you're working on AWS, the best way is to use the IAM service to basically say nobody can directly access the machines and to make any changes. Like as soon as it happens, we can add some alerting mechanism on top of it, and you can enforce throughout the team that every single change needs to go through a pipeline. So the pipeline is the only authorized resource who can make the infrastructure changes. So now, if you have these experienced engineers who have who want to use their old ways of doing it, they just simply cannot access it because we put the guardrails. So I am a big proponent of, and this is also part of this new concept of platform engineering. I'm a huge proponent of putting the guardrails in. So it sounds limiting to like you're limiting your engineers to do certain things, but I think it's actually more liberating because now the engineers do not have to be afraid to click the wrong buttons because the things that they're not supposed to do are kind of prevented by default in an automated way, so they can test out things without being afraid that they're gonna break something. But this is a really good point, actually. Of implementing the tools properly.
So I want to share, this is the IaC podcast, but I'm a founder of a company named N0, and I don't want to talk about what N0 is doing. I want to focus on the content here. I just want to share the story of why we started N0. or what was the first aha moment for me. And I remember I was working with a big insurance company. I was not an employee, but I worked for a company that had a customer, a big US insurance company, US based. And we had a bug, and we needed to change some configuration in the load balancer, the ELB of that customer. And I remember I've asked that engineer, can you please change the configuration in your cloud account and let's see if it's working? He said, yeah, sure, I'll do it in a sec. And then I noticed that instead of clicking a button in AWS, he opened, in that case, GitLab, opened a Git repo with Terraform code, merging and executing that code. And then he came back to the AWS, and that was the first time I noticed that he has read-only access to AWS. It's not that he chose to do it via code. He was forced to do it via code, and that prevents drifts and increases the trust and the compliance of that organization. And then I thought, wait, all of your code is in GitLab. GitLab has no awareness of the AWS resources. AWS has a lot of resources, but has no awareness of your code. The role-based access of AWS is just being used in a very simple way of all humans get read-only access, and the Terraform code that you execute in Git has full access to do basically everything. So what's going on? The world has changed. And then I started thinking about the needs and the use cases. But when I noticed that he has read-only access to AWS, that's the first time I talked with a DevOps engineer that is supposed to fix infrastructure issues with read-only access. So that was my moment that I decided that I want to explore more. And I just want to say one more thing back to your analysis of the evolution from Python and Boto API to stateful infrastructure as code. Maybe you mentioned configuration management, and let's talk for a moment about something like Ansible and other configuration management frameworks and tools. So back then, maybe you've used cloud, but good chances you had a big monolith running on a virtual machine, and maybe that monolith uses some big database, uh, maybe an RDS with MySQL or Postgres. So the number of infrastructure changes you needed to do and to remember the state were pretty limited, because most of your changes were within the, let's say, Java monolith on the virtual machine. So you needed something like Ansible that knows very well how to manage the JVM within that virtual machine. But I think two things happened. One is the shift to microservices, normal monolith, and cloud native. Now, if I know that my application is going to run on AWS, I'm probably going to choose S3 buckets as a storage to a lot of my stateful information. And I'm going to use some other concepts that are working very effectively in the cloud, such as serverless. So applications became more complex with a lot of dependencies of different types of infrastructure. So the infrastructure changes became a lot more dynamic. And the old approaches of scripts and even configuration management don't have the state awareness, and therefore are very complicated to maintain at scale. So I just wanted to share my analysis of why engineers keep on changing things and invent new concepts. So when the ecosystem changes, the need for new approaches evolves. Nana, before we finish, I just want to ask a question that I think everybody is asking in the last year or two. What do you think AI is going to do to the work of the DevOps engineer?
Great question. um, okay, so way I see it is for example, if we take monitoring, right, or if we take the automation, it was like automation is the backbone of DevOps, right? Everything that we do is automation first. That's like if we're doing something manually, like there's something wrong. Like why are we doing this? Let's automate it. So AI is also about automation, right? Taking the tedious manual um things off of the engineer's hands and kind of automating. So I think it's like the adoption will be very easy for those who have already adopted DevOps. Now, on the actual role-based context, what I think is going to happen generally in engineering field is right now we have developers who are writing code, or we have DevOps engineers or sysadmins who are writing the infrastructure as code, right? So there's a lot of like when I was an engineer, 80% of my time was writing code or debugging, and then the rest was maybe some deployments and stuff. Um, so what AI is gonna change mostly is taking that coding part away from engineers. So if my major skill is coding, I need to move to the architecture side because AI is gonna automate a lot of it, which is something that is unexpected. Like nobody expected that AI would suddenly be able to write code as good as senior software developers who have been doing it for decades, right? Which is a crazy, surprising idea. So the shift is now, in my opinion, is gonna be the best engineers who will retain the most value will become the architects. Whether you're a software engineer, sysadmin, the engineer, whatever you are doing, data scientists. So they will become the architects who basically become those who say, these are tools that we want to use in this combination. These are the use cases, and how do we map the tool set to our specific use cases? Because you probably know because you work with B2B, every company's systems are very different. Like when you zoom in, like it's very individualized, it's very different, especially if you mix the legacy with modern, it basically becomes this super unique unicorn. So an engineer who can map the specific use cases and company needs to the tool set and then use the AI to kind of for the implementation part. So in my opinion, that's the shift that we're gonna see for people needed to become more architects. And DevOps role itself is actually architect first, because as a DevOps engineer, unlike others, like if you want to be a junior DevOps engineer, you need to already learn at least 10 to 15 technologies, because otherwise you're not going to be able to do the basic job of a DevOps engineer, which is identifying the issues and bottlenecks and improvement and optimization opportunities. So I didn't plan this for our YouTube channel or our courses, but it kind of looks like with AI, the shift is gonna go more to the DevOps side or architecture side, architect role side, but with technical knowledge, obviously, because you also need to be able to validate the output and work of AI.
That's another great challenge to solve. Nana, thank you so much for sharing your experience and thoughts and perspective about our space. I want to deeply appreciate your time. It's been a pleasure talking to you. So thank you so much for joining today, Nana.
Thanks for amazing conversation and discussion. I love this topic, so I'm always happy to discuss with someone.
Perfect. Thank you so much. And thanks everybody for listening. See you next time. Bye.